Good morning, good afternoon, everyone. We'll give it just a couple of minutes here for others to join. Okay, we'll go ahead and get started. Hello and welcome to Oliver Prent and Suncorp White's webinar, a collaborative approach to rigid tray and lid sterile barrier system development. I'm Haley Schraben, Group Product Manager for Oliver Healthcare Packaging, and I'll be your moderator today. We have just a few brief announcements before we begin. First, this webinar is designed to be interactive. So in the right bottom of the screen, you should see both the chat and Q&A functions. If you're experiencing any technical problems, you can use the chat function and we'll do our best to assist you. And you can use the Q&A function to ask questions that relate to the content of the presentation. And we'll have some time at the end of the session today to address those. You can check a box to make sure your question is asked anonymously if you prefer. And now on to the presentation. Today's agenda will begin with an overview of common failures we see in rigid tray and lid sterile barrier systems, and why it's so important to partner with your packaging component and equipment suppliers in tandem to best position yourself to mitigate failure risks. We'll then walk through a series of design considerations so you feel more prepared with the questions you should ask yourself and your teams, as well as your suppliers, to optimize your sterile barrier system and equipment design. And finally, we'll wrap up with lessons learned and best practices. Discussing today's topic are three industry experts. First, we have Jeremy Elwell, Technical Services Manager at Oliver Healthcare Packaging. Jeremy has a degree in packaging from Michigan State University and has over 20 years of healthcare packaging experience across many design and development roles. Next, we have Jesse Winker, Director of Product Development at Prent Corporation. Jesse has a degree in mechanical design from the University of Wisconsin-Stout and has been with Prent since 2007. And last but not least, we have Lynn Barton, VP of Sealing Technologies and the General Manager of Tech Sealers at Suncorp White. Lynn graduated from the University of South Florida with a BA in philosophy. She's worked at Suncorp White for over 20 years, holding various positions, and has a long history of participating in multiple industry organizations, including IOPP New England and IOPP's Medical Device Packaging Technical Committee, as well as AMI. First, let's kick things off with a poll question. How much experience do you have with designing and or launching rigid tray and lid sterile barrier systems? We'll give it just a couple of seconds here so everyone can answer. And pretty good variety. Okay, great. So quite a few that are 5 years and less, and then a few more experienced individuals. That is great to see. Okay. Let's go ahead and move on then. Okay, so Jeremy, Jesse, can you talk to the audience sort of about what we're seeing here?
Yeah, thanks, Haley, and hi, everybody. It's good to see a good mix of people out there, and we're going to go through a few scenarios that a lot of you may have seen because you're 5 years plus. Some of you may not have seen this yet, but we want to show you why we're here and what we're going to try to help you avoid. Here's some pictures of defects, and how many of you have been in a project where you see this very late in the game where you get a warped seal flange or maybe some oversealing, the Tyvek, you can see there transparent Tyvek, or undersealing areas with poor adhesive transfer, maybe some Tyvek tearing in the upper right-hand corner, or the in the bottom right-hand corner is misalignment of a lid. So these are some common areas to watch out for. And our goal in this webinar is to really give you a lot of good best practices and advice on how to avoid these types of defects.
Yeah, because we all know that once these issues come to light, it really can add a lot of time to try to resolve them. When you get into resolving these things, the time that it takes, the money that it takes to redesign and try to fix these things um, are really critical, but we want to try to avoid that on the front end. If some of these things go unresolved, it could lead to other issues, or depending on the severity, putting patient safety at risk.
So now that we know more about some of the failures we might see in the system and how all three of you really are impacted, let's review what each of you do. Jeremy, we can kick it off with you.
Yeah, great. So at Oliver Healthcare Packaging, we're a converter of pouches, die-cut lids, roll stock. We have coating technologies, and we have HDPE backer cards as well. But for this webinar, we're going to focus on the die-cut lidding conversion and coating technologies. And we have two types of adhesives and the coating technologies we'll cover a little bit later. But really, our focus is helping you decide which lid with which coating is appropriate for the application.
And at Prent, we're a manufacturer of custom rigid thermoform trays. We operate primarily in the medical, also the high-end consumer electronics and automation tray systems. We take that process from initial concepts all the way through the design phase into high volume production. Medical is by far our largest and core market that we serve. At Prent, we're largely focused on medical sterile barrier systems, and that's what we're going to talk through today.
Hi, everyone. So SenCorp White began in 1947. So we have decades of experience providing constant heat pouch sealers and tray sealers, along with tooling, as well as custom solutions for sterile packaging applications. We specialize in providing highly accurate and robust equipment designed to meet the stringent requirements for the medical device packaging industry. And to that end, we have engineering, manufacturing, assembly, and full aftermarket machine service capabilities in-house. But most of all, we just pride ourselves on our unparalleled customer support.
Great, thanks. So why is it so important for packaging teams and their related stakeholders to partner between all of you, the tray, the lid, and the sealer supplier throughout the development process?
Yeah, so to make sure the objectives for the final package and overall project are achieved, it's important for all three key stakeholders who are critical for the creation of the sterile barrier system to understand those objectives. If we each operate in a vacuum and don't cross-functionally develop that sterile barrier system with the customer, we can inadvertently create obstacles that can ultimately undermine the sealing process. So you'll hear during this discussion that we are very much aligned on the benefits of some key elements for the package. And then there are other specific inputs that we each need, which can have dramatic impact on the success of the project. For example, communicating what I need as an equipment manufacturer to Prent and Oliver to ensure the customer's SOP is robust can make the difference between a seamless, low-risk packaging process or a challenging, awkward sort of sticking a square peg in a round hole type of situation. So clearly understanding the customer's packaging requirements and working together as a supplier team will make the entire project less risky and more productive just from the get-go.
Yep. And when we, on the front end, a lot of times we get involved at Prent with the tray design. We're working with our customers on a lot of different potential paths and tray designs. Once we start to narrow those things down and things get a little more solidified, any little bit of change from a tray design can have a ripple effect down to the other partners here, SenCorp or to Oliver. So we really need to, be communicating and talking through those things as things change in the process. It's really what we want to get across is one system that we're trying to develop across all three partners.
Exactly. And Jesse and Lynn, just like the other two components that they've mentioned, the lid highly relies on the tray and sealer design and selection of both. So we're going to reiterate the fact that working with all three of us is essential in your success with development.
Great. Okay, let's pause for just a moment and let's poll the audience again. What parts of the rigid sterile barrier system are you responsible for? Tray, lid, and sealer? Tray and lid? sealer, or some other combination not listed here. Just another couple seconds. Okay, great. So most of you, a little over half, responsible for all three components. That's great. But are some in the audience that are maybe responsible for just one or two of these pieces? So I think this will be particularly beneficial. But I think between the experience we saw in the earlier poll and this, there's going to be a little something for everyone as we continue to move forward. All right, out of here and we'll continue on. All right, so between the three of you, what is the ideal design process? When do you prefer that each of you get involved?
Yeah, for sure. So on the start end, we're working on the tray design. Usually that's what we're coming up with, the system, the kit, whatever it may be, to protect that product. And once we get into that tray design process, sort of near the end of that design process is where we would recommend that you start to begin your sealer selection and notify the lid supplier. So we want to start to bring in all three of these partners somewhat early in the process, just at least to begin the communication and know that the project is coming. So that way, once we get into where we do the tray finalization, the design finalization, the conversation can start to kick off in a little more earnest, where some of the next steps can begin to happen. But we don't want to be kind of at the end and have to circle back to begin the sealer and the lid. So tray design freeze is critical, and we want to start having those conversations before that.
And when you notify us for the die cut lid, early in the process is always recommended, as Jesse says. We're going to start thinking about material interaction, what adhesives to select with what tray material you're using, dimensional aspects, and any kind of opening features. So at that point, we're going to be working on it, but we don't lock in our design until the tray is complete. Really, the lid is going to follow the dimensions of the tray. So it's important to work together on these, but also have the tray frozen and designed first.
Yeah, and if we have a general idea of what the tray and lid size and design elements are going to be, we can start working on equipment sizing and tooling concepts like number up for maximizing throughput, and process development and optimization, which we'll talk about later. But we can do that while the tray and lid designs are being finalized. We can also start discussing sealing risk mitigation features and communicating back to all of our Imprint package attributes that would be helpful for achieving that before they do their design freezes. So just making sure we're all communicating during this process is critical.
And as we all know, oftentimes things change. And so we need to go back through and to do a redesign, maybe product changed, maybe more product is added into a specific tray. Whatever the case may be, if we go back and start to do a redesign, that's where we do need to make sure that you're being that conduit to the three partners here so that we can all know what's going on. It might be something small that changes, but maybe it affects something in the seal tool, or a corner radius that seems not like it's not a big deal, but it could affect the lid. Different things. We just want to make sure that the changes are being communicated depending on how long the design has been in a freeze standpoint. So really, again, communication is key back to all three suppliers if something changes.
Great. So now that we've established why it's so critical to partner with all of you at various points in the design process, let's get into the important design considerations and how they impact both the packaging components and the sealer equipment. So Jeremy, let's kick it off with you. What are some general considerations that really impact the lid design specifically?
Yeah, Haley, there are mainly three buckets here: material selection, adhesive type, and really adhesive style, zone coat versus flood coat. This doesn't take into consideration dimensional aspects, which are very important too, kind of straightforward. But the other three main buckets here for the material selection, You want to think about what you need for your base material of the die cut lid. Do you need breathability and porosity, or do you need barrier properties? Tyvek is the most common lid that we produce here at Oliver, but we do have other options with paper, film, and foil. And that foil layer can give you barrier properties if that's what you need, but you're lacking with breathability there. So lots of options to consider. Adhesive coating, we mentioned this before and we'll keep mentioning it, but the compatibility with the tray, the adhesive selection is very important because some adhesives aren't compatible with certain trays, and others are very much recommended for certain tray material, as well as sterilization type too. If we're putting this terminally sterilized sterile barrier system, we want to consider what sterilization types, since the interaction of these materials can differ in each modality. Adhesive types at Oliver, we have two different types, water-based and hot melt. We won't go into detail on these, but each do have their benefits. We sell both of them and we convert both. And there is a lot of resources out there to learn more about those two. But for the purposes of this, we want to mainly focus on material selection and the compatibility of these adhesives with the tray material. And then zone coat and flood coat, the style here. Zone coated lids in the bottom left. There's an option. This is more of a specialty product where the adhesive is available only on the outside where the tray flange will be, and there's no adhesive in the middle. So that's a specialty product to limit the interaction of, let's say, a device with the adhesive itself. But the more common approach is a flood coated lid, as shown in the bottom right. That's when the adhesive is available fully all over the lid, and this is much more common. So those are two types of lids to consider.
Okay, great. Thank you, Jeremy. Before we jump into focus on the tray, let's do another audience poll. So what type of flange design do you typically incorporate into your rigid tray? Flat, raised, or not sure? Okay. All right, looks like a little bit more on the raised flange, but also a good number of not sure. So that's very interesting. Jesse, I think we're going to hop into you to talk about tray design next, and I know you'll be hitting on that point. So let's go ahead and start there.
Yeah, great. The flange design is one of the most critical places to start from a tray design. We want to make sure that we're going down the correct path to what our customers need. Flat flange design has been in the market for many, many years. It definitely has its place, but ultimately the raised flange design is where we want to be going. It does offer a little bit more robust process from a thermoforming standpoint and from a seal process development standpoint. It's a little more flexible. It allows our customers to get a little better operation window in the raised flange design. So ultimately, that's where we want to be from a design standpoint, is in the raised seal flange design. I know Lynn's going to touch on that a bit as well. The next things to consider are the tray sidewall features. As we're designing a tray, we're looking for ways to get sidewall contact that can locate the tray within a seal nest for repeatability. So if we have a really flat tray, sometimes it can be difficult to orient the tray within a nest, or if we don't have good sidewall contact, things can go in one way one time and a different way the next time. So we really want to be looking at that from a tray design standpoint as well as we're laying out a tray. When we're looking at lid coating and the sealing die, I know Jeremy mentioned, zone coat versus flood coat, and Lynn's going to be talking about the sealing die as well, whether it's a sculptured or relieved seal head or a flat seal head. Those play a factor in the tray design as well. So, the decisions that we're making on the lid and the decisions that we're making on the machinery and seal tool standpoint can have effect on how we want to design that tray and how we want to position the product within the tray. So as those decisions change, it can affect the other partners here on the call, or if those changes are done in those areas, it could affect how we need to redesign the tray as well.
Okay, great. Thank you, Jesse. So let's hit the audience with a quiz before we move on to Lynn. So quiz, what is the best practice for the minimum amount of seal force in the tray flange? Is it 50, 100, 200, or 300 pounds-feet per square inch?
Pounds of force per square inch.
Thank you, pounds force, thank you. 50, 100. Okay, looks like we've got a little over half answering 100. Lynn, do you want to speak to the right answer?
Yeah, I just want to see the results real quick. Okay, interesting. All right, so, well, no matter how well the tray is formed, there's always going to be some variation in flange thickness. Ideally, no more than 5/1000ths of an inch. You want your sealer to be able to overcome those flange thickness variations to ensure that the lid is making good, even contact with the entire flange. For that reason, tooling should not necessarily be designed based on how many trays you can physically fit in the seal area from a real estate standpoint, but based on how much force the press can deliver, with a goal of having at least 200 pounds of force per square inch of seal area on the tray. This is kind of, an industry kind of best practice. A lot of medical device manufacturers kind of operate with this goal of 200 pounds of force. And applying at least 200 pounds of force per square inch will provide the highest level of confidence that your lid is making good, even contact with the entire tray flange. Again, that may need to be increased if there's more than 5/1000ths of an inch of flange thickness variation in the tray.
Okay, thanks. Great little nugget. Beyond that little best practice, what are the other design considerations from the
Yeah,
sealer?
so not to just copy paste Jesse's talking points from Brent, but we do have a lot of common design considerations and similar reasons why. So I'll just kind of stick to the most important points from a sealing process standpoint. Tolerances on the tray and the lid have to be considered when designing the tooling, and those tolerances can stack to create challenges for registering the lid to the tray in the tool. And when a flat flange tray is used, higher tolerance can create greater misalignment. So if you have like a Tyvek lid, that can result in fusing of the lid to the tray, and that can delaminate when during the opening process, those pictures that Jeremy showed in the very beginning. That's one example of what can happen when you have a flat flange tray and a Tyvek lid and not great alignment. Maybe you don't have a little extra material overhanging and that lid can fuse. And so raised flanges have that unsealed area around the perimeter of the tray, around the flange. So misalignment becomes a little less risky. That's why kind of all of us like to see those raised flange trays. Most of the medical device packaging market uses flat die plates. There are sculptured dies that definitely have their place. Just bear in mind that they are designed specifically for the tray geometry. And so you have tool changeover if you're going to use a sculptured die. And you also need to make sure that you are having really precise registration of your tray to your sculptured die. That becomes a non-issue when you're using a flat die. Also, if you have a sculptured die and you have any damage to the die, usually the equipment manufacturer is not going to have spare dies to your design in-house, in their stock. So you need to make sure you have a backup in your inventory. Otherwise, you could have machine downtime if that die plate does get damaged. You don't have that issue with a flat die plate. Equipment manufacturers are always going to have flat die plates in their inventory. And then the last thing that we really like to consider is if you're going to be doing single piece flow or multi-piece flow, the medical device industry is really going towards single piece flow, meaning that they start and finish one tray at a time. So they pick a tray, load it into the tool. There's one nest in the tool. And they do everything for the operation of sealing and offloading that tray before they start the next one. That reduces the risk of operator errors and maybe missing something in the tray. So we do see that a lot in the medical device industry is going that direction. And then operator SOP. Now, what is the operator going to be doing as their standard operating procedure in processing that tray? And how can we as an equipment manufacturer help mitigate those risks? And because it is a very manual process, and just make sure that everything is being done properly. And there's a lot of things that that equipment manufacturers can do to help with that and prevent inadvertent mistakes from happening.
Great, thanks. And I love that there's some copy and paste among all three of you here. I think it just really further establishes why it's so important that all three of you are involved early on, because you all generally care about some of the same things, right?
Absolutely.
Okay, so let's move on. We're going to kind of go back and forth between all three of you for these next topics. How do process parameters impact the packaging system?
So continuing the theme with the lid and adhesives, very important about understanding your adhesives and when they start to activate. So when we're heating up adhesives or the coating on the lid, you're activating all of the ingredients in there. And at lower temperatures, partial activation can happen. So you may see some transfer to the tray material at lower temps, but you may not get a very good adhesive transfer. So it's important to understand that during a DOE, the low end and the high end, when you're starting to activate, when it's fully activated, when you're getting a good seal, and then at the high end, if you're going too far in over processing. So it's very important to know that.
Yeah, and from a tray standpoint, one of the things that we're going to hit on here in the next slide as well is and when we're looking at tray materials, and one of the most common materials that we're going to be using from a sterile barrier system standpoint is PETG. So PETG's forming temperature range is typically 255 to 285. It can fall anywhere within there depending on the design and where the specific design wants to form. But PETG in itself you can form trays as low as 255 technically, and as high as 285, maybe even a little bit more. So that's typically where we're at from a thermoforming standpoint.
Yeah, and from an equipment standpoint, you really want to be targeting the medium material process window, but also, what the equipment min and max is, and really targeting the middle of the range. I mean, there's obviously, if you don't want to be operating at the equipment's very low end of what its capabilities are, and or at the very high end, you really kind of want to be trying to target that median range. And for example, if you're at the very low end of pressure, there's something called stiction, where the press actually has to overcome that stiction to be able to actually start to move. And if you're below that stiction rate, it becomes a little bit variable about how that press is going to start its movement and how it's going to overcome that stiction force. So making sure you understand what the equipment process range is, and then try not to operate at the extreme high and low ends of that, will give you the greatest repeatability and the least amount of variability.
And this shows just a different way to look at what we've been talking about. But first, on the left-hand side, you'll see an animation. This is a diagram of the sealing process, just a rough diagram to show the heat and how it travels through each substrate. So it's important to understand this concept when you're performing a sealing operation, that you're not just activating the Tyvek and the adhesive. The heat is conducting throughout the whole system, through the Tyvek, adhesive, tray or film, even, and then to the sealing gasket itself. So when you are performing DOEs and process validations, it's really important to understand that the heat is going to be traveling down and what that means for your parameter set. And then on the right is a seal curve. And for those of you that aren't familiar with a seal curve, this is a way to profile different material combinations at different temperatures. In this case, we're keeping the sealing conditions for time at 3 seconds and 50 PSI gauge pressure. So we fluctuate the temperatures, and you can see there, you know, at the low end, you're still getting a pretty good of this particular coated Tyvek, you're still getting a pretty good peel strength value at about 1.5 pounds per inch at the 220 Fahrenheit set point. But at that point, you may get poor seal transfer. So it's important to understand, even though you're getting a good peel strength, it may not be a full seal at that point. And then at the other end, at the high end, you may run into a little bit of over processing. So it's important, again, to know both sides of the seal curve for the adhesive.
Yeah, and when we're looking at the sealing process, specifically temperature, one of the things that we need to consider is the PETG forming window. So when you're choosing your temperature for the sealing process, if you do get into that 250 to 260 range, where you might often find your sealing process, that's right in the window of where you can start to reform the material itself, the tray itself. If your dwell is too long or going, you know, you're heading towards maybe an over processing, over sealing. If you're in those temperatures and you dwell for too long, you can start to reform the tray seal flange. That's when you can start to see curling or warping or any number of different things where the tray starts to deform, because technically the longer you hold it there, you're going to start to reform the tray at a certain point. So that's just something to watch out. It's not to stay away from those temperatures necessarily, but if you are in those ranges, you can start to see those issues for sure.
Yeah, and I like to, there's something I know, you know, anybody who's sat down with me for more than 5 seconds has heard me say, you know, low and slow is really kind of the best practice. You kind of want to make sure that you understand what the individual material process windows are and what the process window overlap is. So understanding, you know, where the adhesive is going to activate, and then, you know, what the PETG process window is, and then targeting that on the sealer. And, you know, one of the things that I always try to make sure people understand is also, you know, cycle rates. There can be heat buildup in that gasket if all of a sudden you start cycling that sealer really fast and you start building up heat. That's where that temperature can start to kind of creep up, and you start activating that PETG tray and start getting that curling, is because the temperature in the system really likes to be, you know, nice and stable. So you need to be low and slow is kind of, you know, the mantra that we use in the medical device industry for the most repeatability.
Great, thanks. That was really excellent information all. Let's hit the audience with one more poll question before we move on to the next topic. So have you ever been asked to use a legacy packaging system or universal packaging system across different device families or device generations? Just a simple yes or no. Let's see, answers still coming in. Okay. Okay. Looks like we're at about a 70-30 split, with the majority of you being in this situation. There's no surprise there, and that's exactly why we wanted to include this in the presentation as our next topic. Let me get myself back over to my slides here. Okay, so Jesse, this one's really focused on you. What does the audience need to consider when they're using a legacy design for a new or next generation device?
Yeah, this does come up quite often, and you know, there's good value in being able to utilize some of your system, you know, a legacy system, whether that's a seal nest, seal head combination with just a new tray. We get that request a lot, and the things that we really need to consider are, you know, if it's a legacy design, how was that nest built the first time so that it can interact and fit within the nest appropriately. As you can look through these 4 different tray versions that you see there, they're the same seal flange, but that interior geometry can play a big factor in whether it's actually going to fit within that nest, depending on how the nest was built the first time. If the nest was built around design number 3 here, you know that it's got a big open area and can accept pretty much any of the geometry that you would want to put within that seal flange footprint. If the nest was built around number 4 per se, and it has some tack seal points in there, then you're going to be really limited on what you can put into that nest in the future. So when we get into these different design considerations, different designs that we want to put into an existing nest, it's definitely something that we want to be either communicating, knowing who the seal nest supplier is, so we can work with them, work with Lynn's team to get the CAD for that seal nest so we can design appropriately on the next set of trays, or have drawings, have communication, images, pictures, things that we can try to use to make sure that whatever we go down that path, you know that you can count on that nest. Because if you find out at the end of the party that you need a nest, then things are going to be a little bit slower, and things are going to get delayed for sure.
And I wanted to just add that, looking at these different drawings that Jesse has here, it's all the same flange geometry when you look at the perimeter of the tray, but the geometry internally can affect the flange thickness variation. So going back to that earlier poll, the 200 pounds of force per square inch of flange thickness, of seal area, number 3 may have a very even flange. You've got a lot of just simple geometry in that tray. And then you get to number 4, and that flange thickness might have more variation in it, which may affect how much force you need to deliver into the seal, the sealer to deliver into that flange to be able to overcome those flange thickness variations and making sure you're getting a really good seal of your lid to your flange.
Great, thank you. So Jesse and Lynn, back to you two. What is a poka-yoke design and why does it matter?
Yeah.
So, sorry, go ahead, Jesse.
Yeah, sorry. Poka-yoke. So poka-yoke itself really just means to mistake-proof or error-proof. So when we talk about poka-yoke in the sealing or in the tray design standpoint, it's really trying to make it so that it is, somehow asymmetrical in some way, that it forces people to load this into the seal nest in the same way each time. From a tray design standpoint, often we can do this fairly easily with peel tabs. So in the top picture there, we got peel tabs on the left. So it adds like a chamfered corner, essentially, that, makes it different from the opposite side of the tray. Pretty straightforward, but sometimes our trays can't always be like that. You need to have a uniform perimeter for whatever reason. So that's where, Lynn's group would get involved with other types of features.
Yeah, so from a tooling standpoint in the sealer, having a poka-yoke design can help ensure that the operator is putting the tray into the machine in the correct orientation, and then also orienting the lid correctly onto the tray if that's a concern. So, as you can see in this picture on the lower left, there's definitely, a right way and a wrong way to put that tray into the tool. And even if you have a tray that doesn't necessarily need to have internal geometry that, for the product, and it's a fairly even symmetrical tray, Jesse can design features into the tray that we can use to ensure that the tooling is poka-yoke and that the operator SOP is followed for making sure that it's oriented correctly and the entire process is followed. Even if you don't need it from a product standpoint, it can be designed into the tray just from a process standpoint.
And from the lid perspective, on the left there is a lid sealed to the seal platen. So if you've gone through this and seen this, you know that this is very difficult to clean up, and it can be quite a mess. And this can happen if the lid isn't identified in the right orientation. And it's really not always easy for an operator to identify which side is the side with the adhesive that's supposed to be down towards the tray. So it's important to identify the orientation, and a couple ways on here to do that. The printing on the top, you can add some pre-print, or even if it's an open here symbol, that helps identify the side that should be up. And then also we have the ability to add a blue tint to the adhesive, to the coating. So that can help identify the seal area that needs to be placed down. So just a couple ways to help avoid this this thing that you want to avoid with the lid sticking to the tray sealer.
Great. Okay, let's talk about prototypes. When is it okay to use tray or lid prototypes in the process?
Yeah, for sure. The prototyping process that we use is vacuum forming. So we machine a soft tool that we will vacuum form a like material onto it, similar to what you would see in a production setting. You know, PETG is very common prototype material that will translate into production. The difference though in prototyping is really the quality of tray that you're going to be receiving. So from a fitment, you know, sharing these with the lid supplier or the seal supplier, you know, Jeremy and Lynn's team can use these to fit and do some other things, but you know, really just want to make sure that you understand that the quality of them, the thicknesses, flange thicknesses, etc., are going to be different when we get into production tooling. So it's not really meant for a quality standpoint, but a sizing standpoint would be okay.
And from the lid perspective and prototyping, we can cut out square cut lids in our lab. They'll have the square corners, but they'll have the same adhesive as production, but they won't go through the die cutting process in production. But this can help for quick turnaround. If you want to do a process development or engineering study, we can turn these around rather quickly so you can get an idea of the behavior and interaction with the adhesive and the tray material.
Yeah, and from a tooling standpoint, I mean, we can design the tooling based on prototypes. If there's going to be a significant change to the geometry of the tray, we may need to change out the top plate. We may need to make some modifications to the top plate. Depending on how far along you are in the design, prototypes are absolutely fine for us to take. We like getting samples. It kind of tells a story that we don't always get in drawings, but if you need to use drawings to communicate to the equipment supplier, 3D SolidWorks is definitely better than 2D CAD. That also provides some additional information, but you know, we always like to get samples, even if it's prototypes. Just it definitely tells a story that we don't get in drawings.
Okay, great. Next topic, Jeremy and Jesse, what do we need to think about when it comes to sterilization?
So as I think everybody is aware, EO and radiation, gamma radiation, are still the most common types of sterilization out there right now in our industry. So typically those two are not impactful to adhesives and tray materials. There are some exceptions, of course, but when considering some novel modalities or alternatives to those two, you know, you want to really understand the material interaction. At Oliver, we have over 30 different adhesive products, different coated Tyvek and other substrates. And some of those are suitable for those alternative modalities and some maybe not. But for example, we have a steam sterilization scenario, and this is another seal curve where we're showing a steam sterilizable coated Tyvek sealed to 20 mil polycarbonate. And the lower curve is non-sterile and the upper curve is post-sterile after steam sterilization. You can see that the output of seal strength on an average is much higher. So this, during that kind of harsh environment of steam sterilization, you know, it can change the profile of your adhesive and change the properties. And some adhesives just aren't designed to withstand that as well as a tray material. So it's really important to understand what type of sterilization you're going to go through, even if you're switching from EO to something else or gamma to something else. You want to really understand the compatibility, as they will differ in different materials.
Okay.
Yep.
Oh, anything you want to add, Jesse?
No, not really.
Okay.
Jeremy
Okay.
had the heavy lifting on here, but you know, from a
Okay.
tray design standpoint, it's really just, you know, making sure that we have the right material that's going to marry up with the sterilization.
Okay, great. Well, then last topic before we start to wrap some things up. Can you talk to us about tack seals?
Sure. So tack seals are areas of the tray inside of the perimeter flange that are tack sealed to the lid. So a lot of times you're designing tack seals into your tray to prevent product from migrating from one part of the tray to another, or making sure that different products don't move around in there. So these are areas of the tray that come back up to the plane of the flange. And one of the things that can affect the sealing process is making sure, again, that you calculate that into the amount of force you need. So that 200 pounds of force per square inch of seal area is not just the perimeter of the tray and that flange area, it's also the tack seals in the interior part of the tray.
Yep, and from a design standpoint, as Lynn said, we can put tack seals in many places that the customer, may find them useful. So it's just a matter of planning and communication between us, you, and your seal nest supplier, because as Lynn said, it needs to go into the calculations and they have to be able to design around that. And then from a tray design standpoint, having something in the middle could eliminate the need for maybe a lid, or it can help hold light product in a certain location. You don't have to use snaps. You can use the lid to hold, or use the tie-back lid to hold things down rather than another retainer piece. Tack sealing, we can also design into putting a retainer in and intentionally tack sealing that to the lid so that it gets removed when you go to open the lid, open the tie-back lid. So there's a lot we can do with tack sealing, but it's just an important communication that needs to happen because it affects all of us.
And with tack seal, may be obvious to most of you, but no zone coated lids. The adhesive's not in the middle of the lid, it's just on the outside. So in this situation, a flood coated lid is the appropriate selection for a lid.
Great. Well, with that, why don't we talk through some of the key points that were made today? So Jeremy, Jesse, Lynn, what are the major takeaways for the audience? Jeremy,
Yeah, I think we had a lot of them. So hopefully it came across well. But just to summarize, design considerations for the lid, material interaction, sterilization modalities, application all come into play. Those are true for the tray as well. And then a very key point Jesse brought up is the raised flange is preferred for sealing for a lot of reasons. I know we recommend that from Oliver as well to do that with the tray for the design. And then the sealer, the tray and lid, are going to drive a lot, and they all work together. So the point is design together, and all three of these affect each other. And then balancing process parameters, just find that sweet spot, the adhesive activation, the tray forming temperature, the equipment high and low that Lynn had mentioned to avoid. You want to understand all three of your situations there, all three of the components and how they work together, and really find the best that matches all three of their prime area.
Yeah, and when we get into legacy designs, whether that's legacy tooling, legacy footprints that we need to stay within, we just need to make sure that we have all the information, whether that's from the lidding side, making sure that you have all the ODs squared away, and from a tray design standpoint, we need to make sure we've got the tooling and the CAD established and understood. So there's just we don't want to do a lot of assumptions because it's legacy and it exists, that it's easy. There's a lot of pieces to the puzzle we just need to make sure we have in place. And then for prototypes, I think for all of us, they're good for look and feel and fit and getting the process going. But when things change, we definitely need to be going back and forth between everybody.
And for poka-yoke, just making sure that we understand what that operator SOP is going to be, and making sure we can help with making sure the operator's doing what they need to do, designing some of those elements into the tray and lid so that we all make sure that that operator SOP is followed, working in those risk mitigation features across all three different suppliers. And then finally, tack seals, just make sure that you calculate, that into your seal force, And be aware that, any changes in the geometry of the tray, interior can also affect that flange thickness variation. All of these play into the success of making sure that that lid is sealed to the tray properly and fully to make sure you get a good sterile barrier seal.
Excellent. Thank you, all of you. And I hope this is really obvious at this point, but I'm going to say it one more time. Engaging across these three partners, so your lid, your tray, and your sealer equipment suppliers early and throughout your development process is critical. And it will help make sure that you consider and ask the right questions to ensure you have an optimal design for your specific solution. All right, so thank you again to Jeremy, Jesse, and Lynn. That was a great presentation. We're going to move on to Q&A. We've got about 10 minutes left for that. As a reminder, you can use the Q&A function for this, not the chat box, please. And we've got a few that have already come in, so I'll just start to throw these your way, you three. This first one I think is going to be mostly for Lynn. We talked a little bit about raised versus flat flange design earlier, and also about sculptured versus flat die designs. So the question here is, does it mean that even if you have a raised flange design, can you use a flat die design as well? Or do you need to be using sculptured versus flat dies depending on which tray flange design you use?
Yeah, that's a great question. Ideally, we like to see raised flanges, and that can absolutely be used with a flat die plate. There's absolutely no restriction on the die plate. Die plate design and whether or not we're going to be using a sculpture die or a flat die really comes down to whether or not you're concerned about tack sealing of the product to the lid. So if your product is too close to your lid and you want to make sure you're not going to get tack sealing of that product to the lid, a sculpture die might help with that. Additionally, if there's any concern about heat exposure to the product, recessing that die plate away from the product can help to air is a great insulator, so you can use the air to prevent the heat migration onto the product. So really it comes down to what your sealing preferences are for your product as to whether or not you're going to use a flat die plate versus a sculpture die plate, not necessarily the tray flange. Tray flange can be used with either one of those die plates.
Okay, great. Thank you. This is an interesting one. So we have someone in the audience who uses a tray today, sounds like Pet G, for a medical device, but it doesn't have a lid on it. So the tray is put into a Tyvek pouch that's sealed for its sterile barrier. So the question is, would it be possible to develop a lid and sealer for that tray that's already being used? And I know the answer is probably it depends, but what say you three?
I think we all can answer it probably in our own ways. I'll start with the lid. I mean, and Jesse probably can speak to this more, but the tray needs to be designed to accept the lid, right? Because when I hear a tray inside of a pouch, a lot of the times I see like a clamshell style. But if it's available and has the right seal area and designed to be suitable for a lid, we'd be happy to make one. Jesse, anything to add on that?
Yeah, it really comes down to what the width of that flange, or the width of where you're trying to seal that the lid to. So usually if it's a pouched application, you're not going to necessarily have a female tray where the flange is up top and the whole tray is down below. It might be like a raised or like a tall wall on the outside with a thin edge around it. You're not going to probably have enough seal width on that, or even if it's a pouch tray with a really small flange, you probably won't have enough flange width. So again, yeah, like you said, Haley, it kind of really depends, but it really on the geometry of what that flange would look like, if it's possible or not without changes.
Yeah, and outside of already the concerns that Jesse and Jeremy have communicated, from an equipment standpoint, a lot of times we'll see trays inside pouches that cannot physically fit in a tray sealer. So, obviously the tray length and width is going to need to be sealed, underneath a platen. And if, like we see this with catheter trays, they for the vast majority of the industry have to go inside a pouch because there are no tray sealers that will accommodate that size of a tray. And instead of making the seal all around the perimeter of the tray, you're putting that inside a pouch and just sealing the very end of the pouch. So there are, reasons why sometimes you're limited to that because there are physically no machines out there that will seal that size of a tray. That's a lot of times when we see trays inside pouches.
Okay. Okay. Another one here. So are there any considerations that one might need to make if they're doing a double tray package? The specific question here is it recommended that the inner and outer tray nests are in one tray sealing tool? But you guys might have some other considerations beyond just that specific piece.
Can I go first?
Yeah, please do.
Okay, so first of all, that great point there, Haley. If you're doing inner and outer on one tool, consider that at the beginning of your lot run, you're probably just going to be sealing your inner and not your outer, and you're going to be, offsetting your die, not only, cocking your die and creating uneven pressure on that inner on inner tray, but also the amount of force that's going to be delivered on just the one tray versus now the inner and outer, because you have to get past that first one, right? The first inner one before you can put it inside an outer one and have an outer one be sealed as well. Also, alternatively, at the end of a lot run, you are, sealing your last outer tray. And if that is, one tool, you have the same considerations. Now you can do things like put a dummy tray inside one or the other cavity to offset that, to make sure that you get the right force and make sure you get even distribution of force across your seal area. You can make accommodations for that. Absolutely. Typically, if you're going to do that, we can absolutely design the tool that way. You just need to be aware of those considerations. A lot of times, like I said, we see single piece flow. So you might have inners on one side of the tray sealer and the other side might be doing your outers. Or you can have different tools for doing, the different process and just switch that out. The other aspect that we've heard about doing inners and outers is depending on how much lid overhang you have on your inner tray and how much that might curve up the wall of the outer tray, you might capture that in the seal of the outer tray. So it's really critical for somebody like Jeremy to understand, that it's going to be an inner and outer tray and make sure that there's enough room there in the outer tray to make sure that that lid doesn't creep up into the seal area for the outer tray.
Right.
From a design standpoint, we really need to know that up front too, so we can build that space like you're talking in the inner or inside the outer to accommodate the Tyvek lid overhanging the inner tray, because there's almost always going to be some overhang. So we need to make up for that, and which can be a challenge because sometimes that looks like wasted space in an outer tray, but really you need to accommodate that or you're going to have some sealing issues with a lid getting stuck between the lid of the outer. The other thing I wanted to point out too, that I've seen in the past when you're doing and sealing an inner and an outer in one nest, you have two different trays and two different tray designs, two different maybe flange thicknesses, flange variations, and essentially they're going to need to use the same sealing process. So you need to make sure that you can find an actual process that overlaps with two different trays, which can be a challenge in and of itself. So if you're doing that, you want to make sure that the tray material thicknesses are aligned specifically so that they can be sealed at the same. You have the best chance at finding process overlap and not going very thick on one and thin on another because the product doesn't need it. Well, if you're going to seal them at the same time, you're probably going to just need to stick with the same gauge, and that just needs to be a consideration up front.
Okay. Great. Well, that is all the time that we have for today. So thank you again to our presenters and thank you to the audience for participating today. Please feel free to reach out to Jeremy, Jesse, or Lynn on LinkedIn if there's any other questions that you have that we didn't get answered today. They're more than happy to connect with you. And to stay up to date on the latest news, innovations, and trends in healthcare, please check out Pack Talk, a blog written by experts for experts. Have a great day, everybody.
Thank you.
Thank you.
Thanks.